Welcome to homeworklib.
If a point with coordinates x, y is reflected in the y-axis, determine the coordinates of the image. We can start this question about reflections in the y-axis by recalling that if we draw a usual coordinate grid, the y-axis is the vertical line. When we are reflecting in the y-axis, that means that the mirror line of the reflection is this line. We need to consider how a general point with coordinates x, y changes when it is reflected in the y-axis. And there is in fact a general rule that will immediately give us an answer to this question. But let's think first about how this rule might come about. We can take any point on the grid, say the coordinates 4, 1, and reflect it in the y-axis. 4, 1 is at a perpendicular distance of 4 units from the mirror line of the y-axis. So the image of this point will also be at a perpendicular distance of 4 units away from the y-axis on the opposite side. This image will be at the coordinates -4, 1. Let's try reflection in the y-axis again, but this time with the coordinates 1, -2. It's at a perpendicular distance of 1 unit from the y-axis. So the image is 1 unit away on the opposite side. And its coordinates will be -1, -2. So far, we've considered 2 points with positive x coordinates and reflected them onto the left side of the grid. But can we plot a point with a negative x coordinate and reflect it onto the right side of the coordinate grid? Well, let's take the coordinates -6, -4. It doesn't matter that this point has an x-coordinate of -6 because we know that we can still work out that this point is at a perpendicular distance of 6 units from the y-axis. So the image will also be 6 units in the opposite direction from the mirror line at the coordinates 6, -4. So what pattern can we deduce from the reflections in the y-axis with all these coordinates and their images? Firstly, we can note that the y-coordinate stays the same in each of the starting coordinates and their images. And it doesn't matter if they're positive or negative, they stay the same. That's because when we reflect in the y-axis, our reflected points won't move up or down. They will be the same height or the same distance away from the x-axis, no matter whether that's above or below the x-axis. But what about the x-coordinates? In our first coordinate pair, the x-coordinate of 4 became -4 in the image. The same is true for the next coordinate. The x-coordinate of 1 became -1 in the image. And if we look at the final pair, the x-coordinate, which was originally -6, became a +6 in the image. In each case, the x-coordinate has changed sign. So if we wanted to reflect a general point x, y in the y-axis, the y-coordinate stays the same and the x-coordinate changes sign. This -x will allow the x-coordinate to become negative in the image if the original x-coordinate had a positive value, and positive if the original x-coordinate had a negative sign. And these coordinates -x, y will be the answer to the question, because it is the image of the coordinates x, y when reflected in the y-axis. And as mentioned at the beginning of this video, this is a general property that we can recall and use. We say that for a general point P with coordinates x, y, a reflection in the y-axis maps point P to point P' with coordinates -x, y. And this is the same result that we have discovered for ourselves.